Hello everyone. I want to talk about one useful thing that the dot product can do for us. So we already talked about the dot product, and the dot product gives us a quick and easy way to find out whether or not two vectors are orthogonal or perpendicular. But it is just giving us, is it 90 degrees or is it not? It doesn't actually tell us what the angle is. But we can derive a formula where we can use the dot product within the formula, and we can actually figure out what that angle is. Okay, so here I already drew two vectors. Let's say that this is vector A, and then we'll call this one vector B. And I put these in standard position. Again, it doesn't really matter. In standard position, they're both starting at the origin, but these vectors could be anywhere. But they do need a common initial point. Okay, and then our resultant vector going between the two terminal points. This is, because of the way I have this pointed, this is equivalent to b minus a. So if I subtract the two vectors, that's what I would end up with. All right. Drawn like this, we do end up with a triangle. Okay, I don't know if it's a right triangle. Not sure what it is, it's pretty arbitrary, but we can relate the three side lengths of this triangle to our angle in between my starting two vectors. We can do that with the law of cosines. So if let me write down the law of cosines. So c squared is equal to a squared plus b squared minus 2ab times the cosine of c. Again, the big important thing in the law of cosines is that the angle that we want to find, or the angle that we're working with, that has to go and match up with the side across from it. For us, we have the magnitude of vector b minus vector a, and then the angle we're working with is theta. All right, so let's plug in everything we know. So c squared, the side across from the angle, the length of that's going to be the magnitude of vector b minus vector a. A and b, these are the other two sides of the triangle, and those are interchangeable. And again, this is going to be the magnitude of each of these. And then minus 2, and then again we have the magnitude of each of the vectors, and then times the cosine of our angle C. Okay, so now we can work with this a little bit. We can do a little bit of substitution here. So one thing we talked about, or we saw in the notes, the magnitude squared of a vector. Okay, so this subtraction, this is still just one vector. I can do this with the dot product as well. So the dot product of a vector and itself, that gives us the magnitude squared. So this is the same as b minus a, so these two vectors, and then dot product with itself. And then I'm going to keep everything the same for now on the other side of the equation. All right, now keep going with this left-hand side. The distributive property does hold true for the dot product, so we can, and not multiplying, but we can distribute all of this. So we end up with, and I'm actually going to move down here so I have enough room. So we have vector b dot product with itself, and then we're going to have minus the dot product of b and a, and then we have the dot product of a with b, and then we have the dot product of a with itself. And then everything else Again, we're just keeping this the same for now. The reason I'm keeping it the same is we are going to get some things that cancel out, which is going to be nice. All right. Commutative property does hold for dot product as well. So these two terms are actually like terms because I can flip-flop the order. So we can combine those together. However, I can actually do something else as well. So up here we said, okay, the magnitude squared, that's the same as the dot product of the vector in itself. Let's go backwards. Here we have the dot product of a vector in itself. That's the same as the magnitude squared. So that's the magnitude of b squared. And we can combine these together like I said. So dot product of a and b. And then a dot itself, that's going to be the magnitude of a squared. All right, so we have a magnitude of a squared on both sides. We have a magnitude of b squared on both sides. This will cancel out. That'll become 0. And we are left with -2 dot product of a and b is equal to -2 magnitude of a, magnitude of b, and cosine of our angle. So now I am trying to develop a formula where it's easy to find the angle that's in between these two vectors. So I'm going to get cosine of theta all by itself. So let's divide everything by -2 and then our magnitudes. And what we end up with, the cosine of theta is equal to the dot product of a and b, that's where we use that, divided by the two magnitudes. So as long as we know the component form for our two vectors, we can easily find the dot product, we can easily find the two magnitudes. Inverse cosine of that fraction will give us the angle between the two vectors.